Hello everyone, welcome back to my YouTube channel. I hope you all are doing well and good. So now the subject I'm going to be talking about is going to be Internet of Things, bearing the subject code 21CS735. So without any delay, let's get into the video. So first of all, the title of this particular paper is Software Engineering for IoT Driven Data Analytics Applications. So introduction to this particular IoT Driven Data Analytics. Definition of IoT DA, a system where interconnected devices, that is things, gather and process data in real time in order to enable decision making as well as automation. Next one is going to be growth of IoT devices. See, by 2020, Gartner actually predicted, that is the author of this paper, actually predicted that there would actually be 20 billion IoT devices globally generating vast amount of data. Application areas. IoT DA is widely used in smart cities, healthcare, transportation and industrial automation, just to name a few. Role of data analytics. IoT devices are going to generate contextualized data. Example is environmental monitoring, traffic management, which is analyzed for insights. Next one is going to be the need for systematic development. In order to handle this complexity of these systems, well-defined software engineering, that is SE processes, are actually very critical. So moving on, we have the challenges in IoT DA software engineering. So first of all, we have something called as device heterogeneity. IoT systems are composed of different devices, sensors, software, creating challenges in seamless integrations. Next one is going to be data complexity. See, data from these IoT devices can be unstructured, continuous and vary in quality, posing challenges for data analysis. So the third point here is scalability issues. With the massive number of IoT devices, scaling this particular system to handle vast data volume is a significant challenge. So the next one here is security and privacy. Data collected by these IoT devices, example is that in healthcare, must actually be secure and protected from breaches, adding complexity to system design. So the last point here is real-time requirements. Many IoT DA applications such as traffic monitoring or healthcare management require real-time data processing and immediate feedback, because see, overall healthcare management is a very important sector. If you are even delaying it by a second, lives could actually be at risk here. So that is actually very important. So moving on, we have the valuation framework for SE in IoT DA. So the first one is framework purpose. The framework was actually developed in order to evaluate and guide this particular software engineering processes used in IoT DA applications. The next one is going to be the key phases. So process planning. Feasibility analysis of this particular project. How feasible is the project? Can the project be done within a particular estimated period of time? What is the overall budget? So on and so forth. Next one is going to be project execution. Involves the engineering and development phases. The third point here is process support. Deals with the tools, human roles and technologies that are going to be required in order to execute the complete project. The next point is derived from academic and industrial processes. 16 processes, that is 8 from academic research and 8 from industrial solutions, were actually studied. The fourth point here is going to be the critical based evaluation. The framework is actually going to use 17 distinct criteria in order to evaluate different SE activities such as requirement gathering, design and validation. So the last point here is focus on process centric development. The framework is going to emphasize the process-centric approaches rather than ad hoc development here, leads to better, more sustainable systems. So this is basically the evaluation framework for SE in IoT DA. Moving on, we have the key criteria for evaluating the SE processes. First of all, we have the functional aspects, that is SR1. Ensuring the system's functional requirements, example is what the system needs to do, are actually being defined. The next one is the quality attributes, SR2, ensuring that the system is actually going to meet the performance, efficiency, reliability, security and scalability needs. The next one is basically the modeling notations, that is MD1. The use of standardized models like UML or ThingML to clearly represent the system design. The fourth point here is architectural design is basically MD2, ensuring the system is designed with a clear architecture, separating data collection front end from processing back end itself. The last point here is validation and verification, that is VV1, testing the system in order to ensure it is going to meet both functional and non-functional requirements before the deployment. So all of these are basically the key criteria for evaluating the SE processes. So moving on, we have the results. So improved system design. The framework has actually helped create a well-structured layer architecture for IoT DA applications. such as Health Connect system, ensuring modularity and scalability. The next point is enhanced connectivity. By using cloudlets as intermediaries between the sensor and the cloud, the system showed significant improvement in sensor connectivity, minimizing data loss during transmission. So result here is that a 30% reduction in connectivity disruptions, leading to more reliable real-time data collection. So next one is efficient real-time data processing. The integration of cloud-based analytics allowed for real-time health data processing, providing immediate feedback to the users and healthcare professionals. So the result here is actually reduced data processing time from several minutes to a few seconds, enhancing the response time in critical scenarios. Moving on, we have better handling of IoT complexity. The framework enabled the development team in order to handle the inherent complexity of IoT DAS systems through standardized software engineering practices. Result was a 25% reduction in development time compared to ad hoc methods. Next one is validated security and privacy. By focusing on quality attributes such as security, the healthcare connection system ensured the safe transmission and storage of sensitive healthcare data, meeting privacy standards. That is example of HIPAA in healthcare or HIPAA in healthcare. Result was a full compliance with healthcare data security regulations, ensuring trustworthiness for end user and medical professionals. Moving on, we have the conclusion. Significance of SC in IoT DA. Software engineering is actually going to play a very key important role in enabling IoT DA applications in order to handle real world challenges efficiently. Standardized framework. The use of standardized SE processes is critical to address the complexity, scalability and the security needs of the IoT system. Future work. The framework and evaluation process can actually be further enhanced with more case studies and by incorporating emerging technologies. Key takeaways. So, the combination of SE processes, clear system architecture and real-time analytics help drive the next generation of smart systems. Next one is going to be the innovation to explore, encouraging audience engagement and exploration of broader applications of these principles in other domains like smart cities and industrial IoT. So I hope you understood all the topics that were dealt in this particular video, and I hope you enjoyed the video. Thank you for watching.